Okay, so what we're looking at here, this is what's referred to as a pith ball. Okay, it's really just a little piece of white styrofoam. It's called a pith ball because ages ago, in the world of physics, what we used for this was the pith of a plant, like kind of like a cork-like substance in the center of some plants. But now we use styrofoam; it works just as well. Now, what we're going to do here is we're going to demonstrate some electrostatic concepts with this, using the pith ball, which is kind of blowing due to the fact that there's central air going on in this room. And we're going to use this conductor here. It is just a rubberized wand. We'll see that it is neutral. It is displaying no interesting properties with the pith ball other than I am poking it. And then nothing happens. But if we take one of these amazing rabbit furs, and the cool thing about our rabbit furs in this class is all of the AP students who have ever graduated out of it have signed one of our rabbit furs, except the class of 2020. If you or a loved one you know knows a member of the class of 2020, please have them contact me. They are entitled to compensation. They deserve to sign a rabbit skin. That's their compensation. But it is what we're going to use in order to charge the rod. Very much like we charge the balloon by rubbing it on our head to polarize it, or to just charge the balloon to begin with, and then we polarize the wall. We're just going to rub this rod on the rabbit fur vigorously, so quickly and with great pressure, so that this rod is now charged. There's a bunch of negative charges. Those electrons are on this rod. And what we'll be able to do is we'll notice as we bring this close to the pith ball, it's going to polarize the pith ball real quick, and it's going to suck it close to it, okay? And if we do this, then boink, there it is. What we've just done is we have conducted electrons to the pith ball. As soon as we touched it to the rod, electrons were stored tightly on the rod. They wanted to get away from each other because electrons are like charges to themselves. And when we touched them to the pith ball, which was neutral, they were able to escape. Now, when we do this, the pith ball wants to run from the rod. And it wants to run from the rod because the rod is negative and the pith ball itself is negative. So we were able to conduct charges over to the pith ball. And we can just see this sucker floating around right there. It's much more interesting than before whenever this thing wasn't charged. Okay? So conducting charges is whenever we physically touch them to one another and the electrons are able to move. Not the protons, the electrons. Now what we can also do here, we'll get rid of this pith ball for a second, is we can look at what's known as an electroscope. Now, what this electroscope is there's a metal ball up here, and it has a metal shaft that descends down, and then on the end of the shaft, there is a little fleck of gold leaf, and you can kind of see it in the camera there, and maybe you can see it in the class. See how when I tilt it, the gold leaf pitches? You see that, how it pitches a little bit? So what we're going to do here is that gold leaf is connected to the metal shaft. And once again, I'll just charge the plastic rod. And what we'll see is that as I bring the rod close, but not touching, to the ball up top, we should see that the gold leaf down below begins to flutter. Okay, so as I bring it close, we see that gold leaf rise up a little bit. And the reason why that's happening is a polarization effect, just like we saw with the balloon in the wall. As I bring these electrons close, it's pushing the electrons from the top ball down into the rod here, and then onto the gold leaf. And then since that rod and the gold leaf are both now net negative, or negatively saturated with electrons, they're going to push away from one another. And because the gold leaf can float, the gold leaf is going to lift up. Okay? So that's what we see right there. Now, when I touch the sphere with the rod, we not only see that we've conducted, but now that gold leaf should stay up higher than it was before. It can't take all of the electric charges, but it should stay up a little higher than it was before due to the fact that we have conducted charges onto it. When I touch my hand to it, we're going to watch the gold leaf drop. And the reason why that gold leaf drops is there were a bunch of electrons right there. These electrons are trying to push away from one another. That's why the gold leaf is floating. Now the electrons are going to run through me and then out into the floor and then onto the earth. We call that grounding something, giving a path of electrons to flow back into the earth, the ground, where there's an infinite amount of space for any electron to go that it wishes to. Now this is where things get a little weird. We've conducted electrons by touching things. Now we're going to do something a little different. Allow me to describe it, and then I'll let you pause this video or pause the class, and we'll think about this for a second, and then we'll see what happens. Here's what I'm going to do. I am going to charge the rod. So the rod is charged, okay? I am then going to hold the rod close. Well, I'm going to place my hand on top of the sphere, and then I'm going to hold the rod close. I am then going to remove my hand from the sphere, and then I'm going to pull the rod away. Here is my question. Will the sphere and gold leaf combination, will it be charged or will it be uncharged? If it is charged, will it be charged positive or negative? Let's pause this video and take a second to think about what you think is going on there. We're back! Okay, so we've unpaused the class and whatnot. We had a little discussion. The current class before us thinks that 1, 2, 3, 4, 5, 6 of us thinks that it will be uncharged. 1 of us thinks that it will be negative. There are an unknown amount of invisible people who think it may be positive. So let's try it out and see what happens. We vigorously charge the rod. We make sure my hand doesn't do anything weird, so I'm just touching it to a lot of stuff to make sure it's neutral. Touch my hand to the sphere. Bring this close to the sphere. I remove my hand. I remove the rod. In the end, we see that the gold leaf is slightly repelled from the base of the rod, just as if I was holding the rod itself just negatively charged. What we'll actually see is as I bring this charged rod close to it, it'll actually push the gold leaf down a little bit. The reason why it's pushing the gold leaf down a little bit is because this is now charged net positive. We have charged it without ever touching it with electrons. Well, not with the electrons that we charged in the rod. What we did here is as follows. And if I touch this, I'll get it to drop back down. My hand starts on this, and everything's negative. When I bring the negatively charged rod in close, all of the electrons that are on this rod to begin with, or on the sphere and the shaft to begin with, before we saw that the electrons wanted to run away and they went down. But now I've given them a second path out. When I touch this sphere, the electrons are going to move through me and get to the ground. They're going to escape as far away from possible because I'm pushing them out with the electrons from the rod. I don't have to touch them to do that. They're just close. They feel the force due to Coulomb's law. So now there are less electrons in the sphere in the shaft. When I move my hand, electrons can either get onto it or off of the electroscope, the ball and the sphere in the shaft here. Now when I move this away, this electroscope has lost a bunch of electrons. If it lost a bunch of electrons, it has to be net positive in its charge. This is also why at that point, when I bring this negative piece back, what was all positive and causing the repulsion at the bottom, I'm still pushing whatever remaining electrons are here down below, which makes the base here with the gold leaf slightly more neutral, or closer to neutral as I could get it, which is why this causes the gold leaf to fall back down, and pulling away causes the gold leaf to go up. When I touch this, I'm bringing it back to neutral, because I'm actually allowing electrons to run through my body and then back on to the electroscope, bringing it back to neutral. This is what we call charging by induction. We're charging something without touching it with the electron charge or the excess electrons themselves. We're doing it by allowing these electrons, to move to and from the ground.